Algebra Unit 11, Lesson 2, Exponential Growth and Decay, Notes in Video 2. All right, continuing on with exponential functions, meaning that we're taking a times b raised to the variable of x power, where our function graph is going to either grow very rapidly or shrink or decay or die very rapidly. Okay, so functions in the form y equals a times b to the x, where a is greater than 0 and b is greater than 1, are called exponential growth functions. So we're now identifying exponential functions as two separate categories, one where is growth and one is decay. Functions of the form y equals a times b to the x, where a is also greater than 0, but the b term or number is between 0 and 1, so fractions and decimals that are between 0 and 1 are called exponential decay functions. And they also have the same general shape. So decay are going to start large and end like they're coming down, approaching 0, where growth are going to start where they look like they're approaching 0 and grow very rapidly. So the most important pieces that you want to think about and remember are these portions here. B is greater than 1 and b is between 0 and 1. So again, think about where b is a fraction or decimal, greater than 0 but less than 1. All right, so here are some examples. For the next few problems, all I want you to do is look at them, examine them, go through, okay, what part of this is A, what part of this is B, and think all that in your head. And from there, tell me which ones of these are growth and which ones are decay. Okay, so letter A. If I was to examine this, our function is y equals abx. All right, so in this, the thing that is being raised to the x power is 7, so that's our b. 7 is greater than 1, so this is growth. Letter B. And in letter A also, if I was to identify and ask for the letter A, which we did last night's homework, A would be 1. Letter B. Here's another example where A is 1 and B is the fraction 1/9, because that's what's being raised to the exponential power, the exponent of x that we don't know. So 1/9 is between 0 and 1, so this is decay. And that's all we're doing for this portion. Just looking, thinking through them, and starting to rehearse these things. What is A, what is B? If B is between 0 and 1, it's decay. If it's greater than 1, it's growth. Letter C. A is 1, because there is no A, so it must be 1. B is 0.75, and 0.75 is between 0 and 1, so this must also be decay. Let's move down to letter E. F of x equals 8 times 1/3 raised to the x power. In this case, A is 8, B is 1/3. We still only care about the B when we're talking about growth and decay. Since 1/3 is 0.333 repeating, it's between 0 and 1. This is also decay. Letter F. F of x equals 4 times 1.2 raised to the x power. In this, A would be 4 and B is 1.2. So the question is B. Is it between 0 and 1 or is it greater than 1? 1.2 is greater than 1, so this is growth. All right, I want you to continue to finish the front of this page on your own, and I want you to rehearse those same words every time to yourself. What is A? What is B? Since we're looking for growth and decay, B matters. Is B between 0 and 1, or is it greater than 1? If you just are writing down words and not thinking through this, you're not going to start to understand and learn the material. So please take your time and work yourself, talk yourself through this. All right, next section of notes. The general equation for exponential growth and the general equation for exponential decay can be represented by capital A equals capital P times parentheses 1 plus or minus r, close parentheses, all raised to the t power. So another thing that we're going to need to memorize is this formula here, and where A represents the final amount, P represents the initial amount from last year, R represents the rate of change, expressed as a decimal also from last year, and T represents time, finally also from last year. The exponential growth equation uses the plus sign, and exponential decay uses the minus sign. So we're going to take this equation and split it up into growth and decay. So growth uses the positive sign, so A equals the principal times 1 plus the rate raised to the time, and then decay is A equals the principal times 1 minus the rate raised to the time. Be careful when you're writing your T's. Again, I always make mine look like cursive lowercase t's so that it doesn't look like a 1. So just be careful with those. Or it doesn't look like a plus sign or an X or a multitude of other things that it could look like. Okay, now we're going to use those two equations. So remember, growth means to get bigger, gain, increase, and decay means to die, lose, depreciate, decrease. On January 1st, the price of gasoline was $2.29 per gallon. That sounds like my P, my principal. Throughout the year, the price increased. Okay, increased. So are we looking for growth or decay? Hopefully you're thinking growth. And the rate is 2.5% per month. What is the cost after 1 year? So I'm going to use my formula. A equals P times 1 plus R raised to the T. Again, I'm using 1 plus because we're increasing, so we're growing. She's going to gain more money. All right, so A equals principal was the original amount was $2.29 times 1 plus the rate to the time. The rate is 2.5%. Remember from last year, our rate is always expressed as a decimal. So we got to divide by 100 every time we have a percent. So 0.025. And the time. And if it's increased 2.5% per month, after 1 year would be 12. So I'm just going to take my calculator and calculate the answer. Label it. You should get $3.08. Remember, in case you're having trouble, when you're raising something to a high power, you're going to use that caret key. Remember PEMDAS, so you have to do parentheses first, exponents, every time, multiply, divide, add, and subtract, every single time. We'll do letter B as well, and I'll let you do C and D on your own. A radioactive substance is decreasing. So, red flag in your head. Decreasing means decay. So our formula is going to be A equals P times 1 minus R raised to the T. And it's decreasing at 3% per year. The initial amount is 25 grams. We're rounding to the nearest tenth after 7 years. So I'm just plugging in all of that stuff into the formula. So I'll say A equals, started with a principal of 25 grams. Oh, it's decreasing, so we're dying or decaying. The rate is 3%, so as a decimal. Time is 7 years. And it's the rate is each year, and there's 7 years, so we're just going to use 7. And again, use a calculator. You were calculating through PEMDAS. You should get 20.2, round to the nearest tenth, grams. All right, go ahead and please try C and D on your own. All right, on the second page, top of the second page, I want to let you do E on your own as well. That's another problem that's talking about growth or decay, and we can use our formula to find that. The next section of the newer part of the notes. So as we discussed in class a little bit, and as you can recall, hopefully from last year, simple interest is the amount paid or earned for the use of money. So if I have a savings account, the bank is hopefully gonna pay me some interest. If I get a credit card, I'm borrowing money, so I'm gonna have to pay them interest as a thank you for letting me borrow the money. It is calculated once per year on the original amount borrowed or invested. The interest does not become part of borrowed or owed, so the principal isn't changing. Our formula then from last year is I equals PRT, where I is the interest, P is the initial amount, or the principal, R is the rate expressed as a decimal, again as a decimal, and T is the time in years always. Compound interest, which again we visited a little bit last year, but we'll do much more thoroughly now, is a special application of exponential growth. Interest is calculated once per period of time on the current amount borrowed. So current is very important. Principal will be changing. Each period, the interest becomes part of that principal. Our new formula is capital A equals capital P times parentheses 1 plus R divided by N, close parentheses, raised to the NT power. All right, where A is the total amount, so our ending result. P is still the initial amount of principal. R is the rate as a decimal, as always. T is time in years, as always. And N is the number of times it's compounded per year. So that's slightly the new piece there. The number of times compounded per year. So words like semi and quarterly, monthly will all come into play here. So let's talk about those first. All right, annually means an event that happens once every year, so N would be 1. Semi-annually means something that happens twice a year. Quarterly, so quarters, think of as something that happens 4 times a year. And monthly would be however many months we're talking about. So we'll just say monthly for a year, so it's going to be 12. If I said monthly for a 6-month period, you would use 6. All right, some examples. Kyra has been babysitting since the 6th grade. She has saved $1,000 and wants to open a bank account so she can earn some interest on her savings. Green Bank pays simple interest at a rate of 5%. If she makes no deposits or withdrawals, how much money will be in her account after 3 years? Well, simple interest, remember, that's way back, 7th grade. I equals PRT. All right, and I'm just going to, again, make the T look a little bit cursive so it doesn't look like a plus sign or anything else crazy. So the interest, I don't know. The principal is that she was saved $1,000. The rate at which she's saving is 5% as a decimal. And how long will she be saving it? For 3 years. So pretty simple problem from way back in 7th grade. We should get the I, once we put this in the calculator, is $150. The question, though, is asking how much money will be in her account. Well, remember she put in $1,000, and she's gaining interest of $150. So in her account will be $1,150. That's an easy way to lose a point. So please make sure you go back again and always reread the problem or the question being asked. Second part, Red Bank pays an interest rate of 5% compounded annually. So that's our new equation. How much money will be in her account after 3 years? So we need our new formula. So capital A equals the principal times 1 plus the rate divided by the number of times it's compounded, raise the number of times it's compounded, times the time. So I'm just going to plug in what I know. Her principal, again, is $1,000. And I keep putting these commas here. You don't need to show the commas in your function equations. Your answers, of course you do. We know how to label money. But in the problem itself, if that is bothersome or makes you nervous because you're just adding little lines here and there, then just wait on the commas until the end. So 1 plus, the rate is 5% as a decimal, so 0.05, over the number of times it is compounded. It says annually, so my n is 1. And I'm going to use n again times t, and t is 3 years. Again, put this in the calculator, take your time. You're still doing PEMDAS. You don't have to type this entire thing in your calculator. You can do one step at a time. So again, maybe simplify what's in the fraction first and then the exponent too. Maybe do that at the same time. Again, your choice, you do not have to do that. Just maybe makes less mistakes for you later. But when you're finished, you should get $1,157. And I'm going to round it to the nearest penny or the nearest hundredths place because we're talking about money. It should be $1,557.63. All right, so that gave you an example of a simple interest problem. And for our new equation, I would like you to do these last four on your own as well. Letter B, it asks again for simple interest, so make sure you're reading them. Letter C asks for compounded. Letter D, compounded. And letter E, compounded. So they're all going to change. The ends are going to change. But for B, you'll really use simple interest, the formula I equals PRT again. Good luck. Take your time. Feel free to rewind, rewatch, whatever you need to do your best on this. Good luck.